This video is going to be about how to use the two different types of oscilloscopes. Now, they will be tested on the unit test on waves and sound and also on the end of the year final. So, you will be reviewing this video later on at the end of the school year. So, let's introduce. First off, we have two different types of oscilloscopes. The first one is called an analog. The second kind is a digital. You will need to know both of the different types of oscilloscopes. These two devices here and here are signal generators. They are producing a signal via this cord, and then the oscilloscope turns that signal into a wave. Now, we'll set these up with different frequencies and different amplitudes. This one is set up at 3000 kilohertz. This one is set up at 6.8 kilohertz. The object of the oscilloscope is to take from this wave, predict what these numbers are. So you, at the end of the year, will have this box. It will be covered in a box, and you won't know what these numbers are. And from this wave, you have to tell me what the frequency, period, and amplitude of the wave is. So let's actually talk about how to do that. We'll start off with first looking at the digital oscilloscope. So we'll zoom in to the digital oscilloscope. And we'll look at the knobs. Now, there are going to be more buttons and knobs than you will ever need to know. So the first one is this one, this one, this one, and this one. All the rest you don't need to touch. Now, the first one we'll talk about is the up and down, the voltage. Oscilloscopes measure their intensity or the amplitude in volts. So first off, this button just moves the graph up and down according to whatever you need. So if you needed to move it up and down to measure it, so the peaks are at the top of this little grid, or the bottom at the top, this bottom of the grid, or do you want it halfway in between, you can change that. The same thing is this button here moves it left and right. Now, these two knobs are what's the most important ones. These represent what the grid is actually representing. In this case, each grid in the up-down direction, noticing the up and down, is 0.5. So the amplitude is 1.5 high. And each one is worth 1.5, as each square is a half. So that's 1. And half of that, it's 0.25, so that is an amplitude of 0.75 volts. Now, there's another term called peak to peak. That is from here, the trough, to the crest. It's double the amplitude, so that would be 1.5, or 2 times 0.75 volts. Now, you could use millivolts if the signal generator was here, which says right here at millivolts. This one, we're on volts. Now, we're going to go up to this one. This one has milliseconds here, then micro, noticing the double-sided U, standing for microseconds. Ours stands for 50 microseconds. So each left-right direction is 50 microseconds. So what we're going to do is we're going to measure from peak to peak. So this is 1, 2, and 3/4. So 1, 2, and 3/4. So 2.75 units, and then you have to multiply that by the 50 microseconds. So if you multiply that, you're gonna get the number of this period. So I'm putting this in my calculator. And that comes out as 137.5 microseconds. To turn that into, we need to change that into regular seconds. So we're going to take the 135 times it by 10 times to the power of -6, -6 being micro. So that's going to come out as a frequency of 0.00013. That is the period of the wave. Now we invert that. 1 over the period is its frequency, and it comes out as 2,272.27, which is relatively close to what we have at 6.8, plus or minus a little error in our readings. So that is how you read the analog. Now let's move over to the digital. The digital is easier to change, easier to deal with, but has basically the same type of buttons. This one moves the wave up and down. Then our horizontal, left and right. This one can change our grids in the up-down direction, and this can change our left-rights. What's great about the digital is that I can just press this auto button and it automatically changes it for me. So it says this should be the best one to read. So again, we just look here though, our numbers are going to be here. Each square represents 2 volts, and that's the up-down direction, and each left-right direction, each square represents 100 micro. Notice the U here. You may not be able to see it very well in the video, but right here it says 100.0 US. Do not ignore this yellow part here. So we're going to read it again. We're going to look at this amplitude. It's 1, 2, 3. 3 times the 2, that's 6. 6 volts is its amplitude. Peak to peak, which is double that. That's from here to here. That is 6 total volts. And that is exactly what the, that is, so the amplitude is 6 and 12 is the peak to peak. Now get the frequency. So I'm going to move this left and right to get a nice even number right there. Now we're going to go 1, 2, 3 and a third. 3 and a third boxes. And so that means that it's 3.33 times, again, this number, 100 microseconds. And that comes up 333 microseconds. Now we're going to change that into seconds, and that comes out as 0.000333. In other words, it is 300 microseconds. This is the period of the wave. The last one is we're inverting that, so 1 over that number, and we get a frequency of 3000. So the frequency is the 3000, and its peak to peak is 12. Its amplitude is 6, and its period is 0.0003. If you have any further questions, please go ahead and ask your teacher.